Hello everyone, this is the 8th video of Dynamic Programming Algorithms video series. In this video, I will introduce the matrix chain multiplication problem and show how to solve it by using dynamic programming. This is an optimization problem to find the most efficient way to multiply a sequence of matrices. To illustrate it, let's consider three different matrices. A is a 5 by 20, B is a 20 by 10, and C is a 10 by 15 matrices. We would like to compute the matrix product A times B times C. There are two ways to do it depending on where the parentheses are located. Either we first compute A times B and then multiply it with C, or we first compute B times C, then multiply A with it. In the first option, multiplying A with B requires 5 times 20 times 10, which is 1000 operations. Since A times B is a 5 by 10 matrix, multiplying it with C requires 5 times 10 times 50, which is 2500 operations. So in total, we need 3500 operations for the first option. On the other hand, in the second option, B times C requires 20 times 10 times 50, which is 10,000 operations. And multiplying A with it requires 5 times 20 times 50, which is 5000 operations. So for the second option, we need 15,000 operations in total. As you see, the first option is much more efficient than the second one. Our aim in this problem is to decide the sequence of matrix multiplications, in other words, where to place parentheses, so that we can compute the multiplication in most efficient way. One of the ways of solving this problem is brute force, like considering each possible option. However, it would not be a good idea since the number of options increases exponentially with the number of matrices to multiply. So for this problem, brute force is an exponential time algorithm which is very slow and not practical for a large number of matrices. To develop a faster algorithm, we will use dynamic programming. Let's start with notation. Consider the matrix product from A1 to AN, where n is the number of matrices. For each I, AI is a di-1 by di matrix. So di-1 and di are the dimensions of matrix AI. Thus, the dimensions of matrix product from AI to AJ is di-1 by dj. For each I and j in between 1 and n, with j being greater, Mij is the minimum number of operations required for matrix product from AI to AJ. Note that Mii is 0 as we don't require any computation to calculate AI. Since we are trying to find the minimum number of operations required for matrix product from AI to AN, we need to compute M1n. We will use a dynamic programming algorithm to compute each Mij. In the first step of the algorithm, we set Mii to 0 for each I. Then, we iterate over each I and j such that they are in between 1 and n, and I is less than or equal to j. Inside these loops, if I is equal to j, then Mij is 0. Otherwise, to calculate Mij, we will consider splitting the product from AI to AJ into two. From AI to AK and from AK plus 1 to AJ for some k between I and j. To find the best split in terms of minimum number of operations, we consider all k's between I and j. For any k, Mik is the minimum number of operations required for the product from AI to AK, and similarly, Mk plus 1j is the one for the product from AK plus 1 to AJ. Multiplying these two matrices will require di-1 times dk times dj operations. So in total, we will need Mik plus Mk plus 1j plus di-1 times dk times dj operations to compute the product from AI to AJ when we split for a given k. To find the best split, we just need to find the k that minimizes this expression. So we can write the recursion rule for computing Mij as you see. Lastly, we return M1n as the minimum number of operations to perform the whole multiplication. The time complexity of this algorithm is order of n cubed, as we have 3 loops and each of them iterates at most n times. And its space complexity is order of n square, as we must store m for each I and j from 1 to at most n. Now, let's code this algorithm in Python by writing a function called MCM. The input of this function is the dimensions t as a list. First, we compute n, the number of matrices. It is the length of the list d minus 1. Then we initialize m as a dictionary and set mij to infinity for each I and j to avoid key error while updating mij. In the first step, we set mii to 0 for each I from 1 to n. In the second step, we iterate over each I and each j greater than or equal to I. We update mij in these loops by using the recursive rule I mentioned earlier. Lastly, we return m1n as the minimum number of operations required to perform the multiplication. To solve the simple example I described at the beginning of this video, we need to create a list P like this. I assure you that when we run MCM function with this list P, we obtain the solution as 3500. I recommend you try and see it by yourself. In this video, I talk about how to solve the matrix chain multiplication problem by using a dynamic programming algorithm. I hope that it was helpful. If you have any question about the problem, the algorithm, or how to implement it in Python, please leave a comment. In the next video of this dynamic programming video series, I will talk about value iteration algorithm and how to implement it in Python.